Welcome back. In this video, we're gonna talk about Demoire formula. So this is a French name. Okay. What do we mean by that? So given a complex number, z, that we can write as r cosine theta plus r plus I r sine theta. This number here, we can say that this is in the algebraic form, which is a plus ib, with a being r cosine theta and b is r sine theta. So our number here can be written also in this exponential form, r e I theta. Remember that e I theta is just cosine theta plus I sine theta. Okay, here to get this formula here, we just use Euler's formula for the cosine. It's e I theta plus e to minus I theta over 2. These are Euler's formula for the sine and the cosine. Here I need to have 1 over 2i e I theta minus e to minus I theta. This is theta. Sorry about the handwriting, but that's part of writing the taking notes. Okay, this is theta notes there. Sorry about that. Okay, here we need to remember this. If we use these ones here, we can get this result. We need to remember something, that the modulus of z is just the square root of the real part plus the real part squared plus the imaginary part squared. Here, if I can use this notation, I can write this as a squared plus b squared. This is the length or the norm of z, or the distance between 0 and z. Okay, so this is, if we graph this one here, we can see that if z is here, okay, this is its image. So here has the coordinates a, b in the complex plane. So here, this is a, b. So this is my b. This length here is the norm. And this angle here is the argument. We call it theta. So this is the angle that the complex number image makes with the real axis. Okay? So you see that we have infinitely many here. Modulo 2 pi. You come back to this angle. The same thing as we have seen in trigonometry. So here, so this is modulo 2 pi. You come back. But we can fix it and we can make it in just minus pi. But we are not going to worry about that for now. Okay? We're going to worry about what's the power of z to the power n. How can we compute that? So given that z can be written in this form, so I'm going to factor by r cosine theta plus I sine theta. Okay, so Demoire is answering this question. What's the formula for z to the power n? Z to the power n, according to Demoire's, is you take the modulus and you raise it to n, and you take the argument and you multiply it by n for the real and imaginary part. Okay, so this is the Moivre formula. Okay, remember that my z is in this form. Why I write it in this form? Because this form here, or this one, has the argument, the angle that I need. Okay, if I don't have it in this form, I can write it in this form. We're gonna do a quick example, and we're gonna use some algebra and Demoire's formula. Okay, so here, if you have z in this form here, and you wanna raise z to the power n, you write it in this form. So the argument get multiplied by n, and the modulus get raised to the power n. So that's the Moivre formula. Now let's work this example here. Let's have z is something simple, 1 plus I. This is simple, but we need to write it in this form here. Okay, so what's the modulus of z? The modulus of z is, according to our definition here, is the square root of the real part squared plus the imaginary part squared. So here, the square root, the real part is 1 squared. Imaginary part is the one facing I, which is 1 squared. Here, that's the square root of 2. Okay? So a quick way is to to find or to write it in this form here is to multiply by the argument or the modulus. Z is square root of 2 over 2 plus I square root of 2 over 2. So I see that I didn't change anything here. So if you multiply square root of 2 by square root of 2 and you divide by 2, you get 1. The same thing here. Okay? And what's this one here? I can write it as square root of 2 cosine theta plus I sine theta. What's this theta here that gives me cosine is square root of 2 over 2 and sine is square root of 2 over 2. It's pi over 4, of course. So I can write this one as square root of 2 cosine pi over 4 plus I sine pi over 4. Okay? Another way to find this angle here is to graph this number here. So this one, as we said earlier, real part, imaginary part. Real part is 1. The imaginary part is 1. So therefore, the image is here. So this is my Z. What's this angle here? So this is 1. And the angle, it's the argument here. We can compute this one here using some simple trigonometry. Okay, and we find that it's pi over 4. Okay, anyways, let's go back here. So I have my Z as square root of 2 e to I pi over 4. I can write it now. Okay, as this form too here. Okay, another thing that I didn't mention here is that if you have this one in this form, you can write it in this form as well. So Z to the power n is Rn ei n theta. Remember that ei theta is cosine theta plus I sine theta here. If I have n here, I'm going to enter n here, and here I'm going to get n theta in both cosine and sine. So therefore, I can write this one in this form here, too. Okay, so this one I can do it too here. Now, my aim is to compute Z to the 500. So we said that Z is 1 plus I. We want to compute Z to the power 500. What we can do now is we can use the Moivre formula. So Z to the power 500 is, what's the modulus? It's square root of 2 raised to the 500 and ei pi over 4 raised to 500. Or I can multiply theta here by 500 and here for the sine by 500. It's the same thing. Let's do both. So here square root of 2 to the power 500 times cosine 500 theta plus 500 theta, which is pi over 4, plus I sine 500 pi over 4. Okay, so this one, what's the square root of 2 raised to 500? It's 2 raised to 250 times cosine of 500 times pi over 4, that's 125 pi, plus I sine 125 pi. Now, using the fact that the cosine is 2 pi periodic, I can see that this gives me, so 2 to the power 250 cosine of 124 plus pi. 124 is 2 times 62. Okay, that means this is just cosine pi plus I sine pi. Okay, what's the cosine of pi? Minus 1. What's the sine of pi? 0. So therefore I have minus 1 times 250, 2 to the power 50. So this is Z to the power 500. So this is using the Moivre's rule. Okay, now I can use what I know from algebra. So I have Z is 1 plus I. I want to compute Z to the power 500. I can use the rules of exponents. So this is 1 plus I to the power 2 to the power 250. Okay, because I know that Z to the power alpha to the power beta is just Z to alpha beta. I use that one here with alpha is 2 and beta is 250. Now I can compute 1 plus I squared. So 1 plus I squared, let's do it here. 1 plus I squared is using the formula x plus y squared. So this one gives me 1 squared plus 2 times 1 times I plus I squared. So it's 1 plus 2I. I squared is minus 1. Therefore, I have 2I. Okay. Now, what I can do is I can enter this one here. 1 plus I squared is just 2I. 2I to the power 50. Now I can use the rules of powers again. So this is 2 to the power 50, I to the power 50, 250. So 2 to the power 250, I to the power 250. So I to the power 250 is what? It's I to the power 2 to the power 125. Because I'm using this rule again with zi as I. Okay, so I squared is minus 1. Minus 1 to the power 125 is always minus 1. Therefore, I have the same thing, minus 2 to the power 50. So z to the power 500 using algebra gave me the same result as the one that I got using Demoire's formula. Okay, I think the main idea that we need to get from here is that if you have z in this form, either this one or this one, and you want to compute z to the power n, okay, raise the modulus to that power and multiply the argument by that power. The argument is both the cosine and the sine. That's what you do here. And this is what's called the Moivre's formula. It's very helpful. We're going to use it a lot. Thank you.